Okay, so 16.1, day 2 or 3, depending on how many days we spent talking about practicing rewriting them using the rules. We're going to work on some word problems. So during a concert, an orchestra plays a piece of music to which its volume increases from one measure to the next, tripling the sounds of intensity. Find out how many decibels, the loudness of the sound increases between the two measures. Let I be the intensity in the first measure, so 3I is the intensity in the second measure. The increase in loudness would be L of 3I minus L of I. So if we take the second measure, loudness, minus the first measure, loudness, we'll get the increase in loudness. So we're moving on to the same problem, haven't stopped. So the loudness of the sound L of I in decibels is given by the function L of I equals 10 times the log of I over I sub naught, where I is the sound's intensity in watts per square meter, and I sub naught is the intensity of a barely audible sound. So what this means for us is we have that L of 3I minus L of I. Remember, that's this. So when we talk about the 3I, that means the initial would be 3 over the initial there of I sub naught. We don't know what I sub naught is other than it is just I sub naught. So this becomes here 10 log 3I over I sub naught minus 10 log I over I sub naught. So I replaced this formula here, up here, and I plugged it in using 3I and I as our values. Now, let's look at what maybe these have in common, because we need to somehow get this down to a numerical value. So they both have a 10. And whenever we're kind of looking at an expression equation, we're going to take out a common factor. They both have a common factor of 10. So this is an I up here. We took out the 10 because it was a common factor. Now, is there a way that I could maybe separate the 3 and the I? Well, if you think back to your rules of logs, it says if it's being multiplied, it actually can be separated by adding. So this 10, it's just going to stay out there. And I can rewrite this as a log of 3 plus the log of I over I sub naught minus the log of I over I sub naught. So I just took this right here and I separated the 3 from the I and the I sub naught. I pulled it out. So now, if I look very closely inside there, I have log of I divided by I sub naught minus the log of I divided by I sub naught. Well, if I take something and I subtract itself off, it just becomes 0. So this leaves me with 10 times the log of 3. Well, the log of 3 is something we can plug into our calculator because that's a base 10. So when I plug in the log of 3 into my calculator, I get a decimal, which is about 0.477. And when I multiply that by 10, I get approximate 4.77. And that is the loudness. So the loudness of sound increases. Let me see if I can write that. So it increases by about 4.77 decibels. And that's it. Not too terribly bad, but using the rules of logs, using a little creative GCF, and we get an answer. We have another word problem we're going to look at. talking about population. So I squeezed it in. It's really long, but I had to squeeze it in off the board. It says the population of the United States in 2012 was 313.9 million. If the population increases exponentially at an average rate of 1% each year, how long will it take for the population to double? The exponential growth model is population equals initial population times 1 plus the growth rate to the number of years, where P is the population in millions after T years, P sub naught is the population in 2012, and R is the average growth rate. So we're going to look at this problem, get it copied down, and we need to look at some key things that we need. If we're looking at our formula, we need to know what P sub naught is, what the population was in 2012, and we have that. We need to take our rate and we need to change it to a decimal. So let's start looking at this. The population is 13.39 million, and that's in 2012. So if we want the population to double, that means that's twice this value, which is approximately 627.8 million. And then we want our interest rate. Our rate is 1%, which is 0.01. Because remember, we want T. We want to figure out what T is. So if I'm looking at this equation, and I want to know what T is, I actually want to solve this equation for T. And in order to do so, I need to get this right here by itself. So I'm going to divide out the P sub naught both sides. And I know it's kind of confusing because we have just some variables here. But if you can bear with me, we'll plug numbers here in a minute. Now, to get a variable out of the exponent, we take the log of both sides. So taking the log of both sides literally means we're going to take the log of this side, and we're going to take the log of this side. When we do that, that allows that T to come out in front. So this side, it stays the log of P over P sub naught. Here, this T gets to come join the front party. Because remember, our rules of exponents say we can do that. And it's very helpful in solving. Now, I want T by itself, so I'm simply going to divide both sides by the log of 1 plus R. And I have a working formula. It is the log of P over P sub naught divided by the log of 1 plus R equals T. So I've got T all by itself. Now I'm in game to actually plug in my values and start to solve for how much time it will take for the population to double. So I know that P is 627.8 million, so the log of 627.8 divided by the log of P sub naught, which is 3.13.9. These are both in millions, so the millions kind of cancel out here. Let me see if I can move this over so you guys can see it. That's divided by the log of 1 plus R, and that's equal to T. But R, we found out, according to our little thing, is 0.01. So we're going to simplify things. This right here is just 2, because remember, it was doubled, right? Here, if I add those together, I get the log of 1.01, and that's equal to T. These are base 10, so we're going to plug it into our calculator and get decimal equivalents. The log of base 2, or log of 2 is 0.301 divided by the log of 1.01 is 0.004. That gives me T. And so when you finish that and divide it, it's about 75.25 for t. Now, what that means, because they asked us to talk about how many years it would take for the population to double. So the population in the U.S. will double in 75.25 years, which is from 2012 to about 2087. And there are your word problems.